Welcome everyone to the Databricks for Advanced Analytics webcast. I am Andrew Kennedy. I'm a BI and Analytics consultant with Thorogood. Just quickly, for those of you who aren't familiar with Thorogood, we're a BI and Analytics consultancy with over 30 years of experience in delivering business intelligence and analytics solutions to leading global enterprise organizations. We work especially combining kind of analytics and technology along with a business focus to really deliver solutions that drive business value. Today's is a particularly technical topic. I want to highlight some of the partners that we work with, but especially here, I think it's worth highlighting Amazon Web Services and Microsoft with their Azure platform. We're partners with both of those. Databricks is available on both platforms. Now, today I'm going to be showing it in the Azure platform. And the relationship between Azure and Databricks is particularly interesting because of how closely Microsoft are working with the Databricks team to bring the two technologies closer together. So first up in today's presentation, I'm going to introduce Databricks and talk through why it's getting quite so much attention at the minute. Then I'll show you around Databricks for a bit and show you how you can use it to analyze your data. And finally, I'll talk through how Databricks fits in the wider analytics project lifecycle and what else you should be thinking about if you're looking to introduce Databricks as an advanced analytics tool. So, what is Databricks? Databricks builds on the open source Spark platform. Now, if you're not familiar with Spark, it's a popular platform for running data analysis and machine learning, particularly at scale. And it's the same team who originally came up with Spark that have formed a new company to launch Databricks. So Databricks takes all of the advantages of the Spark platform and extends it to make it easier to set up and to use, and it makes it ready for the enterprise. Now, one of the ways it does that is by integrating with Azure and with AWS. The Spark requires a cluster of computers to be set up to handle the analysis. Databricks automates the process of setting those computers up. And so it's as simple as choosing the number of computers and the size that you want those to be, and Databricks handles the rest. On top of that, Databricks can handle auto-scaling. So if you use the cloud applications, typically you want to only pay for the computing power that you're actually using. And again, Databricks will automate that process. So that could be a big advantage, big savings if you're running occasional analyses that need lots of compute power for short periods of time. Another way that Databricks builds on Spark is by adding multi-language notebooks. And those notebooks allow users to work in a mixture of languages supported by the Spark platform, whether that's SQL, R, or Python. And you can choose whichever language the user is most comfortable with or whichever language is best for the task at hand. On top of that, it also comes with a number of the most popular machine learning frameworks built in. And again, that simplifies the whole setup of Databricks so that data scientists can go straight to whichever framework is best for the analysis rather than having to worry about installing it separately. And that means that data scientists can spend more time on the analysis rather than the setup of the whole compute environment. Databricks also has enterprise-level security built in, and it's got a number of other enterprise features for, say, collaboration and integration with a number of front-end tools. And all of these features combined really are what's making Databricks a hot technology at present. And we see the interest mainly across two different use cases. The first of those is for ETL at scale. And that's particularly around cloud data sources and data lakes, where Databricks offers a lot of flexibility to connect to the very wide range of data sources and file types. For example, you can use Python scripts and libraries to transform the data, and then output again to whatever file type or data store that you need. On top of that, you get the ability to scale the compute power up when it's needed, and then to turn it off again when you're done. And that means that you can run your processing much quicker than you could if you were constrained by the costs of paying for computers running all the time. Alongside that then, for an advanced analytics use case, you get a great flexibility to switch between languages and to use whichever ML framework you need to approach the business question at hand. And that's a massive plus point for Databricks. On top of that, the notebook format that we'll see shortly allows users to take notes in among the script, which allows the data scientists to explain all the steps that they're taking and to hand over the output as one report, ensuring that the whole analysis is documented and repeatable if any questions should come up. Now, before we dive into Databricks, there are a couple of concepts that I want to introduce, just to give you a sense of what's coming when we take a look at the tool. So within AWS or Azure, whichever you choose, you'll set up a Databricks workspace. And that's a case of filling in a couple of details about billing and account information. And it only takes a few minutes to start up, but after that, everything we're going to look at is within the Databricks workspace. Now, behind the scenes, some of the selections that I'm making when you see me walk through it, those selections will call out to the Azure environment to create and manage resources. But so long as I've got that workspace set up, I'm making all the changes within the Databricks workspace itself, and Databricks is automating all of the complex setup that's going on behind the scenes within Azure. Now, once we get into the Databricks workspace, there are two key concepts that we need to introduce before we can get started: a compute cluster and a notebook. First of all, the cluster. Databricks keeps the options as simple as possible here. We need one main computer to manage the analysis, and then several worker computers to actually handle the computation steps. Basically, the key setting for the cluster is what size I want the machines to be and how many of them I need to have. Once I've got my cluster set up, I'll then set up a notebook, and that's what we use to build up the code that we need for the actual analysis. Now, the notebook concept isn't unique to Databricks, but if it's not something you've come across before, a notebook is a way of writing blocks of code, keeping the output of each block alongside the code that is used to generate that output. On top of that, it gives you the opportunity to write more of a written explanation of what the analysis is doing, so that it's easier to share the output with other users, and that keeps everything together all in one place. Ready to keeping together what's needed to recreate the analysis, so that helps if there are any questions, and it makes it easier to understand if you share it with someone else or if you come back to look at it later. So now I'm going to jump into Databricks in a second and show you what all of this looks like in the actual tool. But what we'll do, first we'll take a look at the Databricks interface to show how you can set up clusters and create notebooks there. And then I'm going to show you a couple of use cases around factory energy usage. The first of those, we're going to look at the ETL capabilities, and then we'll look at one showing the Databricks support for advanced analytics. So what we're going to do, kind of in a diagram on the screen here, we're going to start with some energy data gathered from kind of minute-by-minute calculations here of how much energy is being used by a number of machines in the factory. From there, we'll load that data into Databricks. We're going to run some calculations on top of that, so we'll add some attributes such as the factory ID, the timestamp based on the file name, and then we'll use Databricks to preview the output before we save it back to the data lake for analysis later. Now, in the interest of time, I'm then going to skip a couple of steps where we would sort of run more aggregations of the data, perhaps add in some more attributes. And I'm going to pick up once we've got daily level data for both the energy usage in the factory and also the production volumes for a number of products. We'll take a look at that data and use Databricks to build a linear regression model, trying to figure out how the different production volumes are driving the energy usage within the factory. And we'll take a look at how that process works in Databricks. So if I jump into Databricks, being a cloud technology, it's accessed through the web browser. So this is where I would land if I enter the kind of starting point web address that I get. And within Databricks, like I say, we need to start by creating a cluster. Now, I've already set one up, but just to show you how that would work, I've got this create cluster button. And within Databricks, I get to specify the name. That's just something that I use to refer to it. So if I give it a name, whatever I want that to be, I can choose from a couple of different cluster modes depending on whether I want to optimize for multiple people using it or give myself a little bit more flexibility for analysis for just one user. I've got that choice. And then beyond that, it's kind of, there's a Databricks runtime version, probably best in most cases just to go for the most recent, unless you've got a good reason to change that. The Python version, if you're used to using Python, you'll know whether you use version 2 or version 3. There's a big change between the two, but you can select which of those you want to use within the notebook. But really, the big settings that we set are these three. The driver type, so the computer specifications that we want to use for the driver. And here, these are the different machines that are available within the Azure environment. And if I was working within AWS, obviously it would be the AWS machines that I've got the choice between here. For the workers, I can set a different compute type, like I said, different computer specifications for the workers as I do for the main driver computer that organizes the analysis, or I can have those the same. And I specify the minimum number of workers and the maximum number of workers. So that's how many computers am I using to process the data in parallel. Importantly here, we can enable or turn off auto-scaling. The auto-scaling will allow Databricks to pull back in the size of the cluster and run back down to this minimum number of workers when I'm not doing very much, or expand to the maximum number or any number in between, really, when the workload starts to get heavier. And I've got an auto-termination option, and I can specify how many minutes of inactivity I want Databricks to wait for before actually shutting itself down and getting to the point where it's not costing me any money to run that computing cluster. So depending on what type of processing I'm doing, I can set a different value. So if I'm running sort of one-off analysis every so often, once a month or whatever, I might set that quite low if I'm going to be working with it interactively. Or if I'm using it for work all day, I might set it to 120 minutes. So it's not going to shut down when when I go for lunch, or if I go into a couple of meetings in a row. But if I forget to turn it off before I go home at night, it's not going to keep charging money while it's running, either overnight or over the weekend. And so there's some really important features in there to help you optimize your costs within Azure. Now, like I say, I've already got a cluster set up and running. You can see here it's running. It's got 9 nodes in total, so that's the driver computer and 8 workers. And once I've got that cluster running, I can create a notebook. Now that's done from the front screen here by clicking on Create New Notebook, or I'm going to open one that I've created earlier just so that you don't have to watch me for the whole afternoon sitting and typing code. And this is what it looks like when we get into a notebook. So like I say, we've got several things going on here. First of all, you'll see I've got text up at the top. That's written in a language called Markdown. I'm not going to talk through that too much, but it's pretty simple once you get used to it. You can kind of set up fairly limited formatting, but it gives you enough to make it readable. And then I can write code, and here, with each notebook, you specify the default language, and here I'm using Python. That's not to say I'm limited to Python. I can switch between the languages, and I'll show you that in a minute. But here I'm writing some Python code. This is just connecting to my blob storage, the data lake, to get those to get the Internet of Things files, almost, that I'm getting out of each factory machine. And so I've set up that connection already ahead of time. It takes sort of 30 to 40 seconds. Again, it's not something you want to watch. It's not too long, but that just sets up a connection into Azure Blob Storage. In the next step, again, I'm using Python in a separate block to specify which files I want to pull out of the data lake. And here I'm specifying I want to get all the files with sort of plugs in the name. There might be, files for various different dates or files for various different points in time, and I can use the kind of star and question mark type notation to tell it to load in multiple files. So in this case, I think it's getting around 380 different files. I can run the command, and it will go away. It's going into the Azure Data Lake. It's picking up all the files with file names in that format, and I've specified a few extra changes to make. So take the file name, and from that I want to get the date, the factory ID, the plug ID, some of those different attributes that I want to give in the table that I'm saving back into the data lake as kind of process data that I'll use for analysis later. Now with Spark, I've set up all of those transformations, but it's not actually going to run the transformations until I need the data or until I tell it to run them. And so that's what I'm doing here, and this is the stage where I'm actually going to go back into the data lake, get those files, and save those into a table within Databricks. And so this might take a few seconds longer, just because it's working its way through those 380 files. Actually, it's not going that slowly at the minute. If I wanted during that period, I can go and look at what's happening in the cluster. And if I clicked on the cluster, I can get some details on what's going on behind the scenes if I want. Important to note, you don't have to. I could just stick with my analysis and watch and wait as that's happening. But if I went into the event log, I can see what's happening. So if I'm running a particularly complex analysis, it will tell me here if it's scaling up or if it's scaling down, and I can get a sense of whether I've got a big enough cluster for what I'm doing. Let's go back into the notebook, because that's where we're going to spend most of our time for the analysis. If I go down, it's kept what I've run, and you can see here it's set OK, it's set up that table. And the next thing I'm going to do is preview that data within Databricks. And if I run this statement, you can see that I'm specifying the language I want to use here using this % notation. And I've switched into SQL, so if I'm more familiar with that, I can run kind of select statements, I can use group by, whatever the aggregations are that I'm used to using in SQL. I can run that here in Spark SQL, and it's giving me out it's showing me the first 1,000 rows here. So I can see what the data structure is. Quite simply, I've got a factory ID, I've got plug ID, which corresponds to each machine. I've got a timestamp. In this case, it's just integers, but that's a timestamp that I can use and associate with an energy usage value. And it seems that there's one of my machines that's probably turned off at this point because the first set of values are all 0. Very helpfully within Databricks, I'm also able to switch from using a table view to using a chart view. Here I'm going to switch to a line chart, because that's probably one of the better options for showing this kind of this usage over time. Again, it's still only showing me the first 1,000 rows, but if I go into the customized plot, I can set different settings here. I'm going to group by factory. I want to show time ID across the x-axis, and I want to show the value on the y-axis. So that's the energy usage value. And here, if I press apply, give it a second, it's going to go back and run against that whole data set, and it will draw me a line chart. in the way that I specified, and I can see what's happening in the data here. And very quickly, having loaded the data in from those CSV files, and before I've done much transformation on it, or before I start my analysis, I can see we seem to have something funny going on in Factory 2 here. There's a machine that's been running at one kind of usage level, and it's spiked up, and it hasn't come right back down. That might be a problem with the machine. It might be a data problem. It's something that I'd want to go and investigate before getting too far with the data. So you can see how it's useful to have all of this all in one place, the ability to read data from a large number of files, process it, and then get a quick preview of it before we would save it back into the data lake. Now at this point, I'm going to jump into a slightly further on version of the data set. So here we've got data that we've aggregated to a daily level. We've added in production volumes for 4 products. And we've also added, like I said, we've got the aggregated energy usage across the factory for each day. We want to use this to build a linear regression model, and we're going to use R for that, and show how you can switch between the languages to really get the most of each of them. So if we run a SQL query again here, you can see I've already created this plot of the daily data. Let me switch quickly to the table view so I can tell you what there is here. We've got one factory. Here we've assigned the factory name rather than just an ID. We're looking at the Glasgow data. I've got data for each day in April 2017. I can see how much of product A I've produced, product B, product C, product D, and then the energy usage over on the far right in probably gigajoules or something along those lines. It's a different unit, which means that when I switch into the line chart, unfortunately I'm getting the energy usage in among the product data. So if I was using a front-end data tool that's a more advanced visualization tool, I'd probably split that energy out into a different chart or use dual axis. I can't do that here, but I can get enough of a view to see that there is something going on over this period where my energy usage is dropping lower than the average at the same time as I'm producing only one product rather than a full set of 3 or 4 products. Now that's something that I kind of expect, but it highlights why it might be useful to build a predictive model for this. If I was going to set energy usage targets with a view to reducing the energy usage in the factory, setting one number, just using the average overall, isn't going to give me a very useful measure to track against, because I've got different products being produced at different points in time, and ultimately I might look like I'm overusing energy at some points and underusing at others just because of the changes in those different product levels. So you can see with the 4 products, those are going up and down, and I can see that, and then this energy level it looks at least slightly like it's responding to that, and I want to drill into that a bit further by using a linear model. Now with that, if I move into my next step, this is where I'm loading the data into R. I'll use an R library to load in all the Spark functions, and that gives me access into Spark, and I can run a SQL query against the data set that's sitting within Databricks. So if I run that command, this final function is an R function to show me the structure of the data set. So I'm able to use all the standard R functions that I would use outside of Databricks and get a view of what's happening here. So you can see the data frame. I've got the factory column, the date column. I've got the various different product columns and the energy column all pulled into R, and I can see what format they're in, and it all appears to be appropriate. So I'm going to continue on, can preview the data exactly as I would in R, and I'm going to build my linear regression. So here, within R, we have a couple of options. One is to use the standard R functions that we're using, pull all of the data from Databricks into R almost, and run a standard R analysis. Alternatively, there are specialized Spark functions that will allow us to use the whole scale of the compute cluster to try and run the analysis faster. So it depends on what size your data set is, really, which of those you might want to go for. Importantly, I do need to tell it that I want to work with an R data frame if I want to use the R function. So I've got this as.data.frame function outside the factory data. But what this line of code is going to do, it's going to build a linear model. I'm going to try and model energy based on the data that I have on each of the product production values. I'll run that line of code, and then I'm going to plot some of the evaluation metrics. And this is just standard R functionality here. I'll plot those. Let me actually rerun it just to check that it's giving me the same data here. And you can see that it's giving me like 4 plots. So again, this is the advantage of the notebook here, where we can gather in all of the codes, all of the output, and then put a commentary around that as well, so that I'm keeping all my analysis in one place and I can export it and share it. Alternatively, I could do the same thing and build that using a spark.glm function, which comes with a Spark R library. So if you use the R, you'll know how all of that works. And I'm getting out the same set of results, but computed over using the full scale of Spark to run that computation. So that's what I wanted to show you from Databricks. And now that we've looked at it in action, I'm going to talk a bit more about how it fits into the wider Advanced Analytics project lifecycle. Now, if you've attended any of Thorogood's previous Advanced Analytics events, you'll probably know that we like to use CrispDM as our approach to Advanced Analytics projects. Just to introduce the approach briefly, you start off with a business case for conducting some analysis, with a thorough understanding of the business processes involved, and identifying the decisions that you think you can improve by using analytics. From there, you assess what data you have available, whether that data is going to be sufficient to meet your needs, and you progress to prepare the data for analysis, develop whatever models you need on that, and evaluate the suitability of those models to drive the business decisions that you set out to improve. But once you're happy with all of that, and you're happy with the model, and that it's going to give you the useful insight that you need to deploy the model so that it can be used throughout the organization. And as you can see, this whole setup isn't a linear process. An analyst is likely to move backwards and forwards between different steps to continuously assess the suitability of both the data and the models in meeting the end goals. And that might even mean starting again sometimes, reassessing the business processes and reframing the business questions as required. Now, the reason really that Databricks has captured the attention of the advanced analytics community is its ability to address so many stages in that life cycle. Right from the data preparation stage, where you can use SQL, Python and R in combination to shape the data as it's needed, and then through the modeling stage, where again you can use R and Python along with frameworks such as scikit-learn, TensorFlow, XGBoost, all built into Databricks to give you a wide choice of models that you can use, so that data scientists are choosing between the best model independent of which language they're working in. And then finally, for the deployment step, we have a few options for how we can leverage Databricks. So let me talk through those. Firstly, you can export data within a Databricks notebook. So in the same way that I showed loading data into the notebook, you can use Python or Scala to export, say, to a file in a data lake, and push those results into a SQL database so that you can build dashboards and reports designed to serve the end users. Building on that, you can set up a schedule within Databricks so that whenever you open your dashboards, the data is already refreshed behind the scenes, and the whole process is carried out automatically on a regular basis set up in Databricks. Then if you want, it's possible to combine Databricks with other tools, and say something like Azure Data Factory. You could build in Databricks into your data load pipeline, and what that would mean is that at the same place you set up the scheduled data loads, whether that's daily, weekly, monthly, you can then add an extra step on the end to run the Databricks analysis and output data so that it's ready and available for the user as soon as the data is sitting there and ready for analysis. And one final option, just a little bit different, you can export the model from Databricks so that outside of the tool you can connect the model directly to your front-end application. And that's an approach that you might look into if you need more real-time model results, or if you're looking to make something that's more interactive to specific requests and that users can kind of query on an ad hoc basis, rather than just running it as a batch process once a day to get updates based on the data that's been loaded. And of course, beyond the technology question, there's a lot more to think about, and I want to call out a few things that you should be thinking about in your wider analytics project lifecycle. We've looked at Databricks today, but that's not going to cover all of your analytical needs, so you need to think about the wider tool set that sits within, and think about what tools you need to allow users to find the information they need. It's also important to think about your advanced analytics users and their need to access the right data, whether that's coming from enterprise data sources, third-party data sets. You might have ad hoc data sets that are gathered specifically for one application of advanced analytics, and in any of those cases you need an appropriate way of storing and accessing the data. It's also important to think about training your people. That's both the data scientists that are going to be using Databricks and the wider business that are using the model outputs to drive business decisions. And to get the most value, business users need to be able to understand the context of the model and how it's appropriate to use those to make business decisions that could drive value. Finally, you need a well thought out process around all of this. There are questions to be answered such as how you identify priority business opportunities that can use advanced analytics. What are the validation and evaluation criteria that need to be met during the modeling process? Once you've built those models, then you need to think about identifying the models that are going to deliver the most value, and what steps do you need to make sure that those models are getting in the hands of the right people in an appropriate way so that they can use them to make decisions. So we're going to leave you with those thoughts. So thank you very much for attending. If you have any questions or you want to get in touch, my contact details are on the screen.